Problem 4 says determine dy dx for the following function. So when we look at this equation, we can see that we have a term with an x times another term with x's and y's. So this is going to actually require a product rule. And then we have a term with just a y, and then we have a term over here with just an x. So let's worry about this product rule first. So the first term is x, and the second term is all of this. So the derivative of the first term is just 1. And then the derivative of this, these parentheses right here, are going to necessitate that we use a chain rule. I'm sorry. The derivative of this is 1, and then we just multiply it times the second term. Just getting ahead of myself there. So we just write the term as is. So f prime times g. Then we add that to the first term times the derivative of the second term. So this is going to require a chain rule. So the outside function, right, is just a bunch of stuff raised to 4. So the derivative of that is going to be 4 times, right, that stuff raised to the 3. So then we just copy down what's in the parentheses. And then to invoke the chain rule, we need to multiply by the derivative of the term that's inside. So I have to multiply all of this, so I need parentheses here. So the derivative of x squared is just 2x. But then we have negative y squared. And because this is a y, we're going to have to do a chain rule again with this. So the derivative of this outside function, negative y squared, is negative 2y. And then the derivative of the inside is dy dx. So that takes care of the product rule. Now we have plus 3, or y cubed, so the derivative of y cubed is 3y squared dy dx, and the derivative of 3x is just 3. So now we have to do some algebra and solve this for dy dx, but I can't just start shifting terms yet because this dy dx is trapped inside these parentheses. So I need to make one more pass across the left side of this equation, and I need to be able to split this apart. So the first term is just x squared minus y squared raised to the 4th. But for the second term, what I need to do is I need to multiply all of this by 2x and then multiply everything by negative 2y dx. So we'll deal with the 2x first. So 2x times 4x is 8x squared times x squared, that should be an x, not a y, minus y squared cubed, and then I need to say negative 2y times all of this. So negative 2 times 4 is negative 8, x times y, we still have our x squared minus y squared cubed, and I'm just going to part the dy dx at the end. So if we look back, we can see 2x times 4x, there's our 8x squared, we just drag this down. Negative 2y times 4x is negative 8xy, and then we also had to bring this term down. Then we just copy everything else. And now I'm ready to finish solving for x. So I'm going to take the two terms here with the dy dx, and I'm going to leave them on the left side. And just to make it a little bit easier for myself, I'm going to go ahead, since they both have dy dx's, and factor that out. So I have 3y squared minus 8xy times x squared minus y squared cubed all times dy dx. So we can see if I distribute the dy dx back, I get these two terms. Now, some of you may be wondering why I wrote it in this order. I just don't like to start an expression with a negative sign if I can avoid it. It's much clearer here to me that it's a negative. So if you had written negative 8xy, this stuff, plus 3y squared, that would have been fine. It's a personal preference. Then we move all the terms without a dy dx over to the right side. So this term is positive, so when I subtract it from both sides, this term is positive, so when I move it, it gets subtracted from both sides. And then the final step to get dy dx by itself will be to divide both sides by this. So dy dx is 3 minus x squared minus y squared quantity to the fourth minus 8x squared times x squared minus y squared quantity cubed all over 3y squared minus 8xy times x squared minus y squared quantity cubed. And that is our final answer.